Hello. This lesson is about volume for prisms and cylinders. I think I spelled prisms wrong. My bad. Um, we can correct that. Just insert that S right there. All right, so what is volume? When you think of volume, we talk about surface area being the outside of a three-dimensional shape. What is volume? Take a moment and write down what you think it is. Volume is a measure of the amount of space contained in a solid. So when we're thinking about this bucket, we think about, well, how much water or rice or sand could it hold? So how do we measure volume? Well, when I ask students what volume is, sometimes they don't actually tell me what it is. They give me a formula. And the formula they often give me is length times width times height. And that's great, but that's not volume. Again, volume is the amount of space contained in a solid, right? This formula can get you the amount, but it doesn't work for all shapes. So when you say the volume is length times width times height, does that apply to a cylinder? Does it apply to you as a person, the earth? Is that how you would find it? So this is only particular for rectangular prisms. But I'd like to start from here, like how do you calculate it? What do we say about when we say we have volume? So if you take this formula, you would do 3 centimeters times 4 centimeters times 5 centimeters. And 12 times 5 is 60, but you are also multiplying the units too. Centimeters times centimeters times centimeters is centimeters cubed. So what we're really saying is that there are 60 1 by 1 by 1 centimeters cubed in this shape. That's what we're saying. So when we're looking at any shape, we're dividing it into cubes, even irregular shapes or curved shapes. So this is why we make it a decimal, because it's not a full cube. You may only have a part of a cube, half a cube, fourth of a cube, just some weird shape of a cube, but not the whole cube. So how do we find this for other shapes? We'll really think about what we did. So let's look at other prisms. So how do we find a formula for the volume for all prisms, not just rectangular prisms? So if we're looking at it, well, what do we know? All their bases are different, right? Every base has a different shape. So how do we take that into account when that's a pentagon and this is a hexagon and then this base is a triangle? Well, let's look at a different kind of prism. All right, so this is a hexagonal prism and the base is here. So it's not sitting on its base, but the base is here. Okay. And then you can see there's 2, the height is 2 here, because there's 2 layers of that, right? So you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 units cubed. Well, that layer is 10 units cubed. What about this back one? This one underneath? Well, that is also 10 units cubed. So there's 20. So there's 10 in one like level, right? And then there's another. What if I had an extra height, right? I mean, extra height. What if I had an extra layer? What if the height of this prism wasn't 2? What if it was 3? Well, then that would be 10 plus 10 plus 10. 10 three times. Well, what if it was 4 the height, or 10, or 20? So it's this area of this hexagon, right, times by the height. And that's what happened. So would that work? So if I found the area of this base and multiplied it by the height, would it get me the volume? Right? Because you would just have the different levels, right? They would all be 1 unit in height. Would that also work for a prism? Sure, right? If I can find the area of this and then multiply it by its height, that would work. What about a triangular prism? So here's the area of your base, and if you multiply it by height, would it work? Yes. Well, is that true for the rectangular prism? Well, let's go back. Is that true? If we found the area of the base, which is 12, which is the same down here, right? And multiply it by how many layers there are, like a cake. This cake would have 5 layers. Did that work? The answer is yes. So, what is that formula? Well, the volume formula turned out to be the area of the base. And this is going to be, and when you say base of the prism, right? Times the height of the prism. Remember, the height or altitude is the distance between the two bases. Now, remember when we say area of the base, this is going to change, right? It'll change according to the shape of the base, whether it's a pentagon, a hexagon, a rectangle, a prism, a square, a triangle. Sorry, did I say prism? A triangle, an octagon, a decagon, a trapezoid, parallelogram. So please remember, this is the area of the base, not the little base, not a base of a triangle, base of the three-dimensional figure. All right, so the volume of the prism is base times height. Now note that it's capital B and capital H, as opposed to little case b and h. So this, again, this will change according to the type of prism. Now there's 2 types of prisms we've talked about, a right prism and an oblique prism. The formula is still the same. Just remember that for an oblique prism, the height or altitude is not the same as its edge. The edge is here. For a right prism, the height and the edge are the same. Let's do a problem so you understand really how that capital B is going to change according to the shape of the base. The area of the base. And changes according to the type of prism. Okay. So let's look at this. So the first thing you have to do is, are they prisms? Like, what shape is it? Sorry, I meant to do that earlier. So clearly they are prisms. I can see that the first one, number 1, has 2 bases. They're parallel to each other and congruent. The lateral faces are rectangles. So write down the generic formula. So V equals capital B times capital H. Now this B, it's an area formula. So remember, this is area of the base. So it's an area formula. So what is this shape? So this is going to be a triangle. So this is our triangle base. So the area formula is going to be, so I'm going to change it, half base times height. Now notice how I write the letters. This base times height is lowercase in relationship to the area. So the capital is the three-dimensional shape, and the lowercase is the two-dimensional shape. So the base of this little triangle, or the triangle here, base, is 2.5 times 7. And the height, the distance between the two bases, the two triangles, is 12. Okay. So I'm going to do half of 12 is 6. 2.5 times 6. Oops. I typed subtraction instead of multiplication. My bad. So it's 105 centimeters cubed because it's volume. All right. So what is this shape? What is the base? Trapezoid. Okay. So the area formula for the base, which is trapezoid, right? It's a trap, is half base 1 plus base 2 times height, lowercase height. Okay, so then we just substitute everything in. So base 1, it could be the top or the bottom. It doesn't really matter. Remember, this height is the distance between the heights of the trapezoid. Remember this two-dimensional shape we're just looking at. And the height, the prism is 10. Okay, so I have 440 centimeters cubed. Okay. Next shape, volume of cylinders. Okay, so what about a cylinder? What do we know? My base is a circle. Okay. Right, so I have that. Well, is it similar to a prism? If I found one layer, right, and then multiply by how many layers, would that be the volume? The answer is yes. So it is just the same formula, the generic formula as in base times height. Now for cylinder, what is the base? Well, that's very specific because cylinders, the base is always going to be a circle. So because of that, the formula will always be pi r squared times height. Oops. Now, is it the same for a right cylinder and an oblique cylinder? Yes. Yes, it is. Okay. Knowing that the height for the oblique is a perpendicular distance, right? An upright distance, the distance between the two bases, the two circles, not the axes, which is here in the middle. But here you can see the height is the same as the axes for a right cylinder. So the formula again is the same for both. But it's really just the same formula as a prism, just the base is circle. All right. So let's see, what do I have? I have a cylinder. So the volume is pi r squared times height. Yes, I write the formula down every time. It's good habit. So when I have harder problems, different problems, and I'm not sure where to go, I always write the whole formula first, including this side. All right, so let's look at this. So this is base times height. But my base now is not a complete cylinder. So it looks a little weird, and you're like, how do you know what it is? It is supposed to be a pipe. So it is here. So if we know that like a pipe, right? It's hollow in the center. Okay. So what is the shape of the base? Well, that base, it looks like an annulus. Right? So just looking like that, looks like an annulus. And it says that from here to here is 2. And on the bottom, it looks like from the center to the outside is 2.4. So from here to here is 2.4. So now, what's the area of the base? Our formula of an annulus is capital R squared minus lowercase r squared. So let's do it this way. Times the height, which is 10. Okay, so I have 2.4 squared minus 2 squared, which is 4. So I have 1.76 pi times 10. No units, just going to leave it. Okay. All right, so what about these problems? Well, these are, what are these problems? What are we looking for? Well, it looks like here I'm looking for the h. Okay, so what's my formula? Formula is base times height. Well, what is my base? It's a circle. Okay, I'm looking for this, and I'm given the r. Oh, look, I'm also given the volume, which gives here. This is why we write the full equation, left and right. Sorry, that's 4 squared. I hope that's okay. I divide out, simplify to 1. So, and then divide by 16. And h equals 7 inches. Okay, let's look at this next one. All right, so what do I see? It's a prism. Okay, so I know the volume is base times height. Give me my this. We're looking for the height again. Okay, so my area here is going to be a triangle. So the volume is 135 times half. The base of the triangle is 6. The height is 4. And then we have x. So this is going to be 12 divide by 12, both sides. I have x equals 11.25 feet. Okay. So these are backward problems. Write the equation, substitute what you know, solve for the missing variable. All right, so here's a summary. Remember, the formula is still the same for both the prism and the cylinder. It's just whatever the shape of the base is, whether it's a circle or a polygon. This is the formula. Here are some tips. Okay, make sure it's a prism and a cylinder. Really know what that base is, so then you can take that and then write the area formula for that. Right? All right. Thank you for watching. Bye.